soon as I get the tab open here, let's see. Christine. Okay, my paper's in front of me. And my calculator. All right. I know you're waiting on me, but I would say all right.
Alrighty then. Should we just start with number 4 then?
Sounds good.
Cool. Alright. So, suppose peer computing sold an average of 45 P phones per minute in 2011. Yes, that means they sold 23,652,000 P phones in 2011 with a standard deviation of 10, and they looked at their P phone sales data and determined that they are normally distributed. Number 4, samples of size n equals 4 are taken from the normally distributed 2011 sales data. What is the shape of the distribution of X? Would it be normal?
Normal, because it's normally distributed.
Yeah.
Okay. Cool. Sample size of n equals 40 are taken from the normally distributed 2011 sales. So that would also be normal, right?
Yes.
Yeah.
And that, I think, is for 2 reasons. Because of the essential limit theorem, because it's over 30 or whatever, and also because of the other reason. Say the reason?
The parent population.
Yeah. Yes, excuse me. What do you need? No, go ahead. Go ahead and do it over there. Thank you. Sorry.
That's okay. And then number 6, a sample of size n equals 4 is taken from the normally distributed 2011 says, what is the probability that the observed X is less than 40? Do we need to pull up that applet?
Yeah, I think so. Yeah. I actually wrote down what I did this time.
Okay.
So how do you use applet for this particular problem?
So, with this one, you're just going to get your z-score, but you're using that new formula.
Oh, okay. The one with the root, square root? Okay.
Yeah.
But is that used for a random sample only? That was only for random samples. Okay, I'm wrong.
I don't know. I think this is because it's supposed to be a sample from the population sample.
Okay.
I don't know if that makes sense, but when I was checking, because I did this one, and so I checked it and it was okay. So I think like for this it is because it's from like a sample from the samples and not necessarily the sample from a population.
Okay.
So you're assuming the overall samples are the population.
Okay, so zx minus u theta root in, or whatever that is.
Yeah.
Okay. So x would be 40, right?
Yeah.
Okay, and then I can figure out the rest. Okay. The sample size is 4. Two.
So right now we're trying to find what x equals, right?
The z, yeah, x.
The z-score? Yeah.
The z.
Z.
Yeah.
Yeah. And then we're gonna put that in the applet.
Yeah.
Okay. So I have a negative 0.416 or negative 0.42. Is that what you got, or no?
I got -1 on mine, but let me do the calculation real quick again, because I know at one point I did where I didn't put like parentheses right, and I ended up getting it way off.
I got -1 also for the z-score.
Okay.
I'm sorry, what did you get? Okay, maybe I'm doing something wrong.
I did my, like above I did the 40 minus 45 separately.
Okay.
And then I used that and then just hit divide by, and then I put in parentheses the 10 divided by the square root of 4. Because I know when I did it a different way, it messed it up.
Yeah,
so.
I must be doing my order of operations wrong then. So I got the -5 on top. And then, let's see, it's an even 2 comes out of the square root. So I forgot, do you add 10 plus 2, or is it 10
divided by 2?
Divided by. I was trying to figure out that operation. I couldn't remember. Thank you. Okay, now I see how you got that. All right, so let me put that into the applet. Okay.
And it's gonna.
And the z-score.
What does it say on the problem? X is less than 40, so it's gonna be to the left. Right? Yeah. That's
okay. So your area was 0.84? Is that right? The middle and the left, because it's less than?
You do left with the -1, because that was your z-score.
Oh, okay, so it's 0.16. Okay.
Yep.
I don't understand. In school right now. All right then.
Alright. These ones kind of threw me. 7 and 8. I went over the text. I went over and over again trying to figure out. So hope you guys can help me with these ones.
Yeah. Actually, I figured out a way, kind of, that I did it with, to know which ones to shade in for the
Okay.
thing. And so I just drew. Well, see if I can show it to you. I don't know where it is. I'm like looking because my screen's really tiny in the corner.
You can kind of see it.
Okay, so like I drew a little distribution, and then for the first Z-score, I knew it was
I'm late.
looking at it greater or something. I think it was greater than, and so I shaded it with one diagonal line, and then I drew the other one, and it was the other diagonal line, and so the part that had both diagonal lines was trying to find it right there. That had both diagonal lines is the one that you're supposed to shade in. I know it's really tiny.
Hey, whatever works for you.
It helped me explain it better. And so I think I started doing that for the other ones. Because on 7 and 8, you get your Z-scores are the same number, just one's negative and one's positive. So
okay, so for number 7, you're doing positive 35 and then negative 55, and you're just doing it 2 different times, and then you're subtracting the difference between your 2 Z-scores?
I did the Z-score of the 35 one, and then the Z-score of the 55. The 35 was -2, and the 55 was 2. And for -2, you know that it's greater than, so it's going to be everything highlighted to the right of -2. But the 55 is everything highlighted to the left. So it's going to be what's in between that area.
Okay, so you used the new formula, plugged everything in, and you just you did that 2 times? Is that what you said? You did it?
I did it for each of them to find the Z-score.
Okay, let me...
And then, because they're the same on your applet,
okay,
you only have to highlight the middle section.
All right, let me...
In the... Let's see. It's X is greater than 35 and less than 55. So pretty much it's just saying that it's between those two.
Yeah, I looked at the answer to see if I can understand it that way. Not to cheat, but sometimes that helps. And it still didn't, like, register for me. I'm like, okay, what? So...
yeah.
Okay.
I got 0.9545.
Okay, well, let me get there first.
Yeah.
So the sample is...
Hopefully by the end of the semester I'm better at explaining things. If I understand it anyway. But
okay, so the first Z-score was a -5 for 30, the one that you plug in 35.
35, the Z-score was -2.
Negative what?
2.
-2. What am I doing wrong?
Are you still using the 10 divided by the square root of 4?
Yeah. Oh, actually, no. Isn't it the square root of 25? Is it the square root of 4 for number 7? Oh, that's why I was looking at the wrong one, wasn't I?
Oh, okay.
Yeah. That's why. Okay. Okay. So the first z-score is -2. Okay. Did you guys already work these all out before meeting?
No, I'm doing it for the first time right now.
Look, I'm the one slowing everyone down here. That's why.
Oh.
I did them, but
I try to
just because I'm like, I
review
want to understand
ready.
it.
Yeah, that's how I want to be ready so I can contribute and be helpful, and understand what I'm doing before, but I didn't have a chance to go through all the group stuff ahead of time.
It's okay. I think
Busy
we're kind of
giving
teaching each
Tylenol
other.
to a child with fever. Okay, let's see.
Oh.
Mhm. So when Victoria, when you set up the second one, do you put -55 -45 on the top of the numerator?
I put just 55.
Okay, because it says less than, so I thought maybe it's -55. No, that doesn't matter, right?
No,
Okay.
you just do it at 55, and then because it's less than, you're highlighting what's to the left of the
Okay,
z-score
that's what
that you
that
get.
refers to. Okay.
Mm-hmm.
So you got a -2 and a +2. All right. And you said highlight everything to the left. Okay.
Of 55. So, it doesn't work if you're gonna, with those areas, to like subtract them. Unless you're subtracting the ends of them, since it's
The
kind of like the tail, like if you're doing, I'm not sure how to describe it that way. If you're,
Okay, so I put in 2, and then, okay, so you want to get,
if you put in 2, since it has -2 and 2 on there,
right.
and you know it's going to be to the right of -2 and to the left of 2. So
Oh, in the
I
middle
drew
part.
I drew a bigger one. I don't
Oh,
know if
let's
it's
see.
going to help at all.
Pretty drawings.
So I put the z-scores on there, and then the one kind of sideways slant is
You're doing the middle is where you have it hashed like that. Okay.
where it's crossed, because it's
Where it's
one's to the left and you ignore the other z-score.
Sure.
So
Okay.
I don't know if that helps or not, but when I
So the
started looking at it,
probability is 0.95.
yeah.
Okay.
And so number 8's pretty much just the same thing.
But your sample size changes. That's the only thing. Okay.
Yep.
All right. Well, you sure made that a lot more clear for me. I was
Oh, good.
the way they set up the answer it just threw me off when I was looking at it.
Yeah. That's why I started drawing little distributions everywhere on my paper.
Oh, that's good. Everyone's in it.
Hey, do you know if, like, on the exams, if we're allowed to have, like, a little note card that has the equations on them, or do we have to memorize all those?
For the final exam or the first
Or
exam?
take the exams that, like, unit exams.
I don't know.
I think we're allowed to do like 1-page notes because that was one of my questions in the very intro week was
Oh,
I'm
really?
allowed to have. So I think you're allowed to do 1 page of notes.
Yeah.
I think next week we have an exam. I'm
Doesn't
just
say it's
looking.
we're probably due for one. Darn it.
And,
No.
and
Because
you know,
our grade is like 50%. What 50% is tests and quizzes. So
yeah. And do you know if we take those quizzes just online at home, or do we have to go to a supervised place?
Those are just online at home.
yeah,
So it's all by the honor system
yep,
because it's an online class.
yep. I've done it before.
Okay. Well, that's
All
good.
right, I'm supposed to be working 8. I'm not doing it yet. Okay.
So we'll just do that at home, but like we can have a page of notes that we did beforehand.
Right.
I think so.
Do we have an exam this week?
Looks like it's next week.
Next
Next
week?
week's week
Okay.
4, right?
Yeah.
It's like we just have the regular prep like normal, and then a group meeting, the homework for it, and then an exam, and that's all we have next week.
Okay, good to know. I haven't looked ahead. Maybe I should have.
Well, I haven't either. I was just looking at it now.
What's the date? What's today? Oh, today's Thursday. Oh, I was thinking today was Tuesday. Wow. Okay, going
Did you
crazy.
start your new job, Walker?
Yeah, I did.
Do you like it?
Yeah, I
Good?
like it
Use
a
the bill?
lot.
Oh, you do? Okay.
Yeah, I like it a lot. It's really fun. I work at a call center, like customer service.
Uh-huh.
So it sounds really boring, like I'm just on phones all day,
Mm-hmm.
but it's really cool. I like it. It's really fun, and I think one thing that makes it really fun are the people. The and
Yeah.
I'm a people person. I like talking to people. If you haven't noticed, I like to talk a lot. So
Well, that's good. If you're going to be a dentist and you're going to be in people's mouths, that's good
yeah.
that you like people. I was just at
Ooh.
the dentist today getting a crown fitted for a
Oh,
crown today, and I thought of you.
that's good.
It was not fun. It was my very first crown. Teach me to take better care of my teeth.
Yeah. You know what's kind of sad? Even though I want to be a dentist, I had to get a root canal one time, and that made me want to take good care of my teeth.
And teach
Yeah.
everyone else to do the same, huh?
Yeah,
Yeah.
root canals are not very fun,
I
but
haven't had one of those yet, so I'm glad that I have not had to do that yet.
I
yeah.
had all my wisdom teeth taken out last summer.
Oh,
I won't be doing those, but well, maybe, I don't know.
Yeah. I don't know. I
Those,
don't like needles, and they're like, we have to put an IV in you, and I'm like, can you put me asleep first? so, so I was like half asleep. I still remember everything, but it was kind of like, I don't really care right now. I'm just gonna sleep, guys, whatever.
Buddy.
22. Okay.
Yeah, I don't see anything in the syllabus that says that anything about preparing for the test. Just says there are 4 exams to be taken on Brain Honey. So,
So, did everyone get the same answer for 8, 2, and -2? Am I wrong on that?
No, that's
Yep.
right.
That's right? Okay, so it's going to be the same. Okay.
Yeah, I was questioning myself too, but then
Right.
so.
Yeah. I guess in my adult life, there's 2 things that I have not done. Serve jury duty and have a root canal, so I'm pretty proud of that. I've evaded both of them, so. All right, we're on number 9. Same thing, or what is the problem that survey is greater than 50? It's the same thing, right, Victoria? But you're just dealing with one number.
Yeah.
Yeah.
So it's
Yeah.
like number 6, I think. Wait, yeah, like number
Yeah.
6.
Like number 6, okay.
But instead of being less than, it's greater than.
Greater than.
Yep.
So that means you're just highlighting To the right of it is what
Yeah.
what it means.
Yep.
Okay, so 49 minus 45. And is 25. Okay, so it's 0.228 or 0.23. Is that right? For the area of probability for number 9?
Did you have it highlighted already to the greater than?
Yeah, I highlighted from just the little tail from to the right.
Okay.
And the z-score is 2. Is that correct?
I have 2.5.
2.5. Okay. I did something wrong then. Okay.
What kind of calculator are you using?
Me?
Uh-huh.
Oh, I'm using my phone.
Oh, so
My
it's like,
smartphone. Yeah.
okay.
I don't have one anymore. I don't know. I've lost it, so I can get a scientific calculator on my phone. So I just use that.
Okay. I was just wondering if you're using something that was kind of like the one on the computer, where it's just like one
I've done
number at
that.
a time, and maybe it was doing weird stuff with it.
Yeah.
Because,
Derivative.
I don't know, I'm that weird person that doesn't like normal calculators. I'm like a weird calculator nerd.
You're particular about your calculators.
Uh-huh. So I'm using like this giant one.
Oh, it's cool.
Thanks. I had a roommate. She was graduating this last fall, and so she had one. She's like, I haven't used this since high school, and I still have it. Do you want it? I was like, sure.
You got all excited about it, huh?
I was like, it was just another one of these. But I was like, yeah, I'm cool with that.
I see what I did wrong. Okay.
Plus, I think it's also because my mom always uses the small ones for doing accounting. And so all the buttons are like rubbed off. And so she just memorizes them, and I'm like, I can't use this. So, yeah. It's okay.
All
Sometimes
right. I got 2.5, and now it's 0.0062.
Yeah.
Okay. I'm on the same page now.
Does your guys' screen only show like one screen at a time? Like one person at a time?
I can see all 3 of you.
Okay. Mine shows like one person at a time, and so sometimes it'll like just really quickly go through all of you. I'm like,
That's funny.
All right.
okay, so let's
All right, Walker, it's your turn to narrate the next part.
Okay. It says peer computing sold an average of 40 p-phones per minute in 2010 with a standard deviation of 12. And they looked at their p-phone sales data and determined that the distribution is right skewed. Samples of size n equals 4 are taken from the right skewed 2010 p-phone sales data. What is the shape of the distribution of X? Would that still be right skewed? Or would that be normal?
I think that's right skewed because the the sample size isn't big enough.
Yeah.
You don't think the sample size is big enough? Really?
Yeah, because it's right skewed, so it needs a sample size of 30 or more.
Oh, okay. On number 10 and 4. Okay. I was looking at the little paragraph above it. I'm like, what? Okay.
No.
I agree with you.
Alright.
And 11, samples of size n equals 40 are taken from the right skewed data. What is this, the shape? That would be normal, right?
Yeah.
Mm-hmm. Or approximately normal,
Yeah.
but it's normal.
And then number 12, is there a theorem that justifies your answer to question 11? Yes.
Yes.
Is the central, is that,
CLT.
what was it called? The central what?
Limit
theorem.
Oh, yeah.
Which guarantees that. The CLT, cheese and lettuce, tomato.
Yeah.
Or cucumber.
Cucumbers?
What's that?
Cucumbers?
Cucumber, lettuce, tomato sandwich? Sure, why not?
It sounds more like a salad.
Yeah, it sounds like a salad between bread, yes. I was a vegetarian at once. Long ago, before I met my husband, and got tired of cooking 2 meals. Like, forget it. I gave it up.
I had a botany teacher, and I don't know why. I don't think he had a thing against vegetarians, but he was just always like, "I love meat." It was just really weird. We're like, okay. And the class was all about plants, so he's always like talking about how when he talked about to his vegetarian friends, he'd say something about plants because they'd all be trying to get him to be vegetarian. It was weird.
That's funny. And then number 13, a sample size, or sample of size n equals 4 is taken from the right skewed 2010 people on sales data, and you want to know the probability that the observed x is less than 35. Can you compute this probability using the normal probability applet with the information you have? Why?
So.
Would that be yes? Because it's more than. Oh, no. Because the data is. Or because the sample size isn't big enough.
Yeah, so because the sample size isn't big enough, it's not normal, and the distribution has to be normal to use the applet.
Mm-hmm.
We could try just so we have that visual confirmation of it, if you want.
Did we do that calculation? Or we did that with the other one, huh? If you want to.
I'll do it on my own, but that's fine.
Okay.
Another time. So no, cannot compute this.
Yeah. Because the sample size isn't large enough to make the distribution normal, and it needs to be normal to use the applet to compute the probability.
Elena, are you missing ice cream tonight?
No, no, they're doing something else.
Oh, okay.
Yeah, it's okay.
How's your sister on her mission?
Good. I got her second letter this week, and she's doing good. Pretty good.
Email or a letter in the mail?
Just email. I think she's gonna start sending letters, because she asked for my address, but we'll see.
Oh, that's cool. Good night, honey.
Where was she at again?
She's just in Provo right now, but she'll be going to Brazil when she gets her visa.
Okay, cool. I think a lot of people go to Brazil. It must be needed.
All right, number 14.
Okay, a sample of size n equals 36 is taken from right skewed data. What is the probability that the observed x is greater than 36.5? So we could use that same equation, right?
Yeah. But you get your z-score and put it in. Same thing as we were doing.
Okay. Let me plug that in.
And it's greater than that z-score. Because it's greater. Yeah, because you want x to be greater than 36.5.
Forty minus 12. Okay, and the sample size is 36. So you got a negative 1.75 on z-score? Is that
Yep.
right? Okay.
You want x to be greater, so you highlight.
So we're just highlighting the tail, right? Again?
The tail in the middle, because it's greater than the negative.
Oh, okay.
I think that part.
How did you
Remembering
determine
those.
that again? I'm sorry, this is going to be a dumb question, but I want to make sure I understand. So how do you know when to highlight? What is the rule of thumb on that?
Yeah, the first time I did it was confusing. I think I got it now though. If x is supposed to be greater than a certain number,
Uh-huh.
then it's everything to the right. So, like if you're putting x is greater than whatever, it points to whatever direction you need to highlight. That's kind of how I remembered it. And then whatever direction you need to highlight. And then your z-score, if it's positive, then you go from the positive z-score.
Okay.
And if it's negative, then you go from the negative z-score.
Okay.
And you just ignore the other one unless it says something else in the question.
So 0.9599 or 0.96? Okay.
That's what I got. So 15 is one of those where it gives you two different numbers to use.
Okay. Use 40. So excuse me, 1.25. What I got.
Yeah, that's what I got.
And so it's the middle because it's between two numbers. And okay, so 0.7887 or 0.79.
And there was one of these in the other prep one that was like that, but instead of doing the one in between, if you were reading it right, it was like the ones on the ends added together.
So
I think that was E.
Is that one of those, or you're just
No.
cautious of that?
That one's, yeah, I'm just saying be cautious of that. So when you're reading it, don't just assume because it gives you two numbers that are the two of these scores. Don't just assume it's the middle one. Yeah, I think that was in the, like, 3E.
3D?
E.
E?
Mm-hmm. As an elephant.
Less than 8 or greater than 12. Okay.
Yeah, so anyway.
Good to know.
Yeah.
Hey, where's Walker? I just see a chair.
I don't go back. Yeah, I just see a chair too.
Sorry, I was just drink water. Okay, I'm back.
Okay. So we're all finished with that assignment then?
Yeah. You guys ready for the quiz?
You want to have a drink of water? Yeah, I guess so.
Quiz 7, right?
Yeah.
Okay, because I...
Tabs. Okay.
Let's see, where is it?
Alright, so... Is everyone there?
Yeah, I'm here.
Hello 7, yes.
Alright. So number 3 says, use the normal probability applet to find the combined area under the standard normal curve that is to the right of z equals 1.358 and to the left of z equals 30. And that's with 3 decimals. So,
Okay.
okay. So,
What is the number we're supposed to do? 1.358?
Yeah.
0.175.
I got
You can lay on the couch and count.
1745. That's what I got.
So then we'll have to round it to 3 decimal places.
Oh.
Zero 0.8255, you said? That's what I got.
175. 0.175.
Did I do something wrong?
So this is actually like one I was just describing. So it says you highlight to the right of the
Oh.
and to the left of the other one. I don't know if that's what your thing was, but
Just the tail part?
uh-huh.
Okay.
So yeah, so to the right of the positive Z and to the left of the negative.
Okay, what was that answer again? I'm sorry.
0.175.
175.
Is that what you got on it?
No, I didn't get that. I'm still trying to come up with that answer. So I punched in 1.358 in the Z-score.
Mm-hmm.
Highlight, you said the right tail and the middle? No.
The right tail and the left tail.
Ah, that's all. Okay. Now I got that. Okay.
What?
All right, number 4. Okay. Mean weight is 185 pounds. And standard deviation 26.7 pounds. The weight of a random sample 48, so n equals 48, and that's random. Okay, sample mean was determined to be 176.6. X bar. Okay. Find the probability that a random sample of passengers will have a weight that is extreme or more extreme than was observed in this sample. Okay. So it's doing the Z-score thing.
Yeah, I'm trying to.
Right.
Alright, I gotta make sure I was looking at that right.
Alright, so what would x equal? That would be...
Yeah, that's it. I think.
I have it as 177.6 because that is the, what did it say? That was the sample mean. That's the, is that wrong?
I think that's the sample mean, but that's like that weird thing.
Right,
So
okay.
we want to find the x. right? So
So x is a variable that's left x. There's nothing to fill into that, you're saying?
um,
No.
yeah. So I think it's asking for what is an extreme, right?
Yeah.
Extreme. So I think that's asking for some. Isn't like 2 is unusual, right? Would that be an extreme? So 2 standard deviations.
Oh, okay, yeah.
Yeah, sorry.
Yeah, anything above 2.
So you'd put 2 in for z.
Oh, 2 in for z, and then x is left as a variable x? Because that's
Yeah.
what you're
So
finding?
I was putting 2 equals x minus
80.
177.6.
Oh, okay.
Because that's your sample mean.
I had
And
it
then,
split up differently.
yeah, I think, and then you're doing divided by 26.7 divided by the square root of 48. And then you solve for x.
Okay.
So,
That's what they come up with.
sorry about this, but what did you say x was? You said it was 2 standard deviations. So it'd
Yes,
be,
so that'd be your z, right? Because your z is usually however many standard deviations away from the mean.
oh, okay. So would
So
that 2?
yeah, because 2 is unusual. That's how I would think of it.
Okay. So we're trying to find x then?
Yeah.
Oh, okay.
So
That's what I was. So we should do. Okay.
does it want an extreme below and above? Or no?
I
Find the
think it,
probability.
I think yeah. So it says find the probability that a random sample of passengers will have a weight that is as extreme or more extreme. So either above or below the mean. So would it have to be like the 2 um, tails of the
I
um,
think so.
probability? Okay.
So are we just putting 2 in for the z-score then? Maybe I did that wrong. The way it's worded just throws me off, I think.
So maybe if we were to, what we could do is, I'll just draw it out. So maybe little applet thing when I draw is not very good. Oh, hey, that one wasn't too bad. Awesome. So the numbers we have are, so the mean is 177.6, and then 1 standard deviation away is 26.7. Okay, so 177.6 plus 26.7. So that's 204.3. And then 159. So that's one. So does this make any sense? Can you even see that?
Um,
You can't even read it.
Yeah. I can like just barely see it.
Okay. So right here I have the mean, and then
Uh-huh.
that's one standard deviation above and below.
Yeah.
So would it have to be the second one? So like I would do another standard deviation away.
Yeah. That's how I was thinking it. Although
And
I'm
then
not sure if you have to do this math or not, or if you have to just add like 2 standard deviations.
Well, can you use the 68, 95, 99.7 rule to go with that if you just punched in, like figured that out?
Well, I think that's for like what's inside of it. So like
Okay.
what's inside, and we're wanting what's on the outside.
Okay.
So like going in.
um
So it's kind of like
so
the opposite.
so would we put, instead of trying to find x, would we try to find z? Because we're trying to find the probability, and in order to find the probability, we need to have the z-score.
Yeah, I think you're right.
So would we plug in one of those? So one of the, just a second, two,
So I think
three.
I was plugging it in to find x, but I think we just need to add the 177.6 plus 2 standard deviations, right?
Yeah.
So like 2
That's what I
times
was doing.
26.7. And that gives you your x that you plug in.
That's what I was gonna do.
Okay.
You lost me. Okay, so does
So
cancel mean 177.6 plus 26.7? Or what are you doing?
so an extreme is 2 standard deviations away. So you do the from the mean. So you do the mean 177.6 plus 2 standard deviations. So 2 26.7.
Oh, okay.
So like plus 26.7 plus
So
26.7.
Victoria, would you do z equals like 231 minus 177.6?
Yeah, I think that's, yeah. So
And then
231,
over
yeah. And then 26.7 over the square root of 46 or 48.
Oh, is it 46?
Let me check. I wrote 48 on the bottom.
Oh,
48.
it's 48? Okay.
Yeah. Yeah, I just messed up saying it.
Okay, so times.
Did you get a really high z-score?
I almost.
Right.
Sorry, it just kept messing up my calculator.
No, that's okay. I got a really high z-score for that, though.
What
So
did
that
you get?
I got 13.856.
Yeah, that's what I got. And that wouldn't really work, would it?
Unless it just means that it's like not probable, but I don't think that's. I think it is probable.
Yeah.
So
Yeah, it's for the probability. I got 1.1702. Oh, wait.
Yeah. To times 10 to the negative 43.
Yeah.
Yeah, that's a lot of zeros.
Yeah, so I don't think that.
Alright. So I feel like it would make sense still to put 2 in for the z-score. Then
Okay. Well, just try that.
sure, and then highlight the outsides.
Yeah. Yeah.
Yeah.
So then did you...
That makes more sense to me.
Okay.
But I mean, you guys are in the class too. What do you guys think?
I'm still trying to figure it out. So are we abandoning the idea of trying to find a z-score because it was just way off the wall? Is that what we're...
Yeah.
Okay. And so how did you reconfigure then? 2 equals x minus 177.6 over 26.7 square root of 48? Is that what you did?
Well, yeah, but because you already have your z-score, you can just put 2 straight into the applet.
Oh.
Does that make sense? Because I was thinking that too, but then I have to... It makes sense to not have to do the calculation because it's asking for the probability. It's not asking for the weight.
Okay, so which number is the z-score? The 177.6? No.
So 2 is going to be your z-score because
it's
that's
okay.
your unusual.
All right, I get it. Sorry, a little dense. Okay.
That's okay. I feel like we were kind of going all over the place trying to figure it out. So. And then you'd highlight the tails of it.
That's what I did, and I got 0.455. Is that right?
Yeah, 0.0455.
Yeah, 0.0.
Yeah.
Okay, do we concur on that?
Yeah, so would that be the final answer then?
Yeah.
I think so, because it says find the probability.
And
Okay.
area
We'll
is
have it.
where you do probability. Yeah.
Yeah, so either above or
so
below.
we have to be to 3 decimal places, so it would be 0.046.
Yes.
Yeah.
Right. And that's important.
Yeah. Okay, moving on.
And then number 5, which of the following will have a smaller standard deviation? 9 observations are randomly drawn from a population. This distribution. That be
So isn't it always the distribution of the sample means is smaller than the standard deviation of that is smaller?
that makes sense, yeah.
But that was one of the things that actually kind of I wasn't always sure on. So correct me if that doesn't make sense or whatever.
Well, I'm just looking at my notes. It says the mean and the standard deviation in the district of sample means does not depend on the central limit theorem, does not depend on sample size, and does not depend on the sample mean of any simple random sample of size drawn from a population. So that would support what you're saying.
Okay.
So then would it then be this cannot be determined from the information given?
uh, 9 observations are randomly drawn from a population.
Because I either didn't take notes on that or my notes don't make sense with that. That's why I'm like, because I remembered reading it.
Okay, what about the law of large numbers? Because that rule states if the sample size increases, the standard deviation and sample means will decrease. Does that have to do with what we're trying to answer here?
I think so. I think that's what I was basing that off of then.
Okay, so
So if your sample size is larger, then therefore you have more population to draw from. The standard deviation of a sample mean gets smaller. So which of the following will have a smaller standard deviation? Distribution of individual observations, distribution of the sample means, or this cannot be determined. So I think it's still the second one. I don't know.
The distribution of sample means?
Yeah, that kind of has to go with the law of large numbers. So
That's kind of how I thought.
how does everyone else feel about that?
yeah, that makes sense to me.
Okay. Should we move on to 6 then?
Yeah. And I think 6 is exactly what we were just talking about, the law of large numbers.
Oh, okay.
It says, as the following results implies, which of the following results implies that the spread in x decreases as the sample size increases, right? Wouldn't that be the law of large numbers?
Yeah, because the law of large numbers deals with your spread anyway, but then also just what we were saying.
But then 9 is not a very large sample to draw from. 9 observations. I don't know.
Yeah. Well, I think it just says that it just means that as your sample increases, that your standard deviation is going to get smaller. So because they're drawing 9, it's from a population already, so it's gonna be smaller than if you did the standard deviation of the entire population.
Right. Okay.
That
So how do we feel about number 5?
I think that's good. It makes sense to me.
Mm-hmm.
I'm gonna go with second choice.
Yeah. And then 6 would be the law of large numbers to go along with that.
Yep.
Perfect. Number 7.
Okay.
7 through 10. Scores on the quantitative portion of the GRE are approximately normally distributed with the mean 150.8 and standard deviation of 8.8. Use this info to answer 7 to 10. All right, Diane answered a score of 160 on the quantitative portion of GRE. What is the z-score corresponding to Diane's score? Okay. So do we just...
I think just find z, like normal. right?
So yeah, so what would the equation be?
So I think that one's just the normal um, x minus the mean over the standard deviation, because they're not using a sample size. They're just saying this person
Right.
scored this. So what's her
Yeah.
what's the z-score? Yeah. So you just do like the 160 minus the 150.8.
150.8 over 8.8.
Yeah.
So z-score. Did you get 1.045?
Yeah, that's what I got.
Not there yet. $1.045.
Yeah.
Mm-hmm.
So 8 looks like we're just using the applet,
Mm-hmm.
right?
Yeah.
With the same stuff. So just put that one in.
So did you? So
You put
then we would just make it be the right tail part.
Um, yeah, so it just goes to the right of the positive z-score.
0.148. Is that what you got?
Yeah, 148.
Oh, maybe I'll do it 0.148 just to make sure.
Yeah.
Are we using the z-score from number 7?
Yes.
Yeah.
Okay. That's us. What are you using?
Yeah, because they have the same score.
Right.
So use the same thing.
And we're highlighting just the middle?
You're highlighting to the right.
To the right, just the tail. Okay.
Yeah.
So 0.15. Oh, 0.
148.
Or
Because you have
148.
to use the
Okay.
3.
0.148. 0.148. Okay.
Yeah. So
So number 9, we just have to find the z-score of all of those. Well, so it says random sample of 5 students was selected to take the GRE. Their scores are those scores. What is the z-score corresponding to the sample mean of these students' scores? So we'll find the mean of all of those scores and then find the z-score.
Right. That's
that's
what
what I
I
was thinking, yeah.
interpret that as.
Okay. Well, I got that the mean is 160. Is that what you guys got?
Not there yet.
Just 1 second. Yeah, I got 160.
Okay, so then wouldn't it just be the z-score would just be 1.045, like number 7?
What is the z-score?
Oh, but would we have to do the new equation we got?
Yeah, I think so, because then you do the standard deviation divided by the sample,
Yeah, I think you're
or
right.
the square root of 5. Yeah.
Because it's
So,
a random sample. That's our clue, right? Because when it's a random sample, we use the one with the square root. That's how I gather that.
Um, Yeah, that'd be why. Also, yeah, because it's a sample in general, I think.
Oh, in
It's
general,
not
not
just it's not just a specific. I mean, samples are supposed to be random, so
right, right.
so yeah. So because it's a random sample,
Okay, so
because the other one was a specific score and it didn't have a anything to compare to with that. So if we set it up that way, what is the x?
yeah, that's I was thinking the same thing.
Wouldn't X just be 160?
I think so, because it's just corresponding to the sample mean.
Yeah.
But wouldn't that just make it 0?
Well.
Because you
So
do.
the mean is 150.8, right?
Yeah, 150.8.
I think I
Because
calculated something wrong then.
right, because wouldn't the mean, well, I mean, like the mean for the just for any student taking the GRE is a 150.8. So wouldn't we still use that mean in this equation?
Yes, that's how I read that.
Oh, yeah, you're right.
And
I was
it's
thinking we were calculating the mean for the new mean. No.
Gotcha.
Yeah, I
listed
got
after
confused.
7 through 10, so we're on
Mhm.
number 9, so we can use that information. And then
Yeah.
our N is 5 students. That's our random sample.
Yeah.
Mhm.
So we're doing 160 minus 150.8.
That's what I
Yeah.
have it set up as.
Okay. Sorry, guys. I got confused.
No worries.
So, does everybody else have their
Yeah.
answers for that?
I got 2.338.
Okay, that's what I got too.
Oh.
I didn't. I'm trying to figure out what I did wrong. Okay. So when you get the square root of 5, it's like 2.236, a long number, right? By
I
8.8.
just put mine in there so I didn't see what the actual square root was. The square root of 5 is 2.23606,
Okay.
etc.
Yeah. And
And then you times it by 8.8. So that's 19.6773, so on.
And what was your final answer on that? G-score?
2.338.
2.338.
Mm-hmm.
Okay. Okay, we just need to put that in. We don't have to do the applet on that one. Okay.
Yeah.
2.
I think 10 is we put it in the applet.
Yeah, that's what I was thinking too.
And then it's just greater than.
So did you get 0.0097?
Yeah, that's what I have.
Okay.
Let me put that in there. Okay, I got that too.
I'm always afraid like I'll start reading ahead and then your
Okay.
computer or whatever will be slower or something and I'll leave you behind.
Trying to keep both screens up, but it's not doing it for me. Okay. Okay, 0.0097 for number 10. On to 11.
Yeah.
All right.
Yeah.
Where are we? Okay, we're at 11. All right.
Suppose the mean GPA of BYU Idaho students is 3.5 and the standard deviation is 0.7. It is well known that this distribution is left skewed. A random sample of n equals 81 students will be drawn. What is the shape of the sampling distribution of the random variable x, which represents the sample mean of the 81 students who are selected? Wouldn't that be approximately normal? Because
Yeah.
it's over 30?
Yeah, because the sample size is large,
Yeah.
and central limit theorem guarantees that it be approximately.
Yeah.
Okay. So, um, what is the mean of the distribution of the sample means? Sample distribution for all possible samples of size 81 that could be drawn from the parent population.
Oh.
What?
So
What is the mean of the distribution of sample means?
so that's like finding the x in the other one, right? Because when we calculated the 5 questions in number 9 or the 5 scores to find the mean,
Uh-huh.
and then that was our x
Uh-huh.
minus the original one.
Okay.
So is that what it's asking for then? Because this is like the mean of means of, or the, this is in, I put the note. When you're looking at your sample means, the sample mean can equal one observation, so like one value. So it equals your x. And then you minus your other mean. I don't know if that made sense.
Okay.
81. That could be drawn from parent population.
So
would that just be 3.5?
I think so. what is it? Yeah, because it's already normally, or it's not normally, but it's all possible samples.
Mhm.
So I think it would be 3.5. Because
One of
otherwise,
those questions that try to throw you. Yeah.
Yeah.
I
I
agree
was
with
starting
that.
to look at it and I was like,
Excuse me.
Okay, so then 13. What is the standard deviation of the sampling distribution of the random variable x, the mean of the 81 students were selected?
that's just,
I feel like I didn't do this stuff.
I think that's just that your standard deviation divided by the square root of the sample, because that's your new standard deviation.
Okay. Oh, okay. So what do we do? 0.7 divided by square root of 81.
Yeah.
0.7 divided by 9, then.
Yeah, I think so.
It's not
I can
rounded
do
to
simple math.
3 decimal places. So 0.078.
Yeah, that's what I got.
Okay. Alright.
0.078.
Mhm.
Yeah.
Okay, now we're getting to the good stuff. 14. So what is the probability that the mean GPA for 81 randomly selected BYUI students will be less than 3.3? So that's just that equation that we've been playing with this whole time.
Right.
Yeah.
Okay, so x would be 3.3 minus 3.5 over zero point 0.7 divided by 81, or square root of 81.
Yeah. And once you get the z-score, you plug it in the applet, right, for the probability?
Uh-huh. So did you get negative 2.571?
Yeah. So, and it wants it to be less than that. So,
Maybe less than 3.3, yeah. So 0.0051.
yeah, that's what I got. Does it still want 3 decimal places?
I think so, yeah.
Yeah. Just that one wanted 4.
Then would we do 0.005?
Yeah, I think so.
What is it?
Okay, so you set it up. I'm back to where you're still setting it up.
Oh.
33 minus 81 is how I have the top. Is that right?
3.3 minus 3.5?
3.3 minus 3.5? Okay. That's
Yeah,
what I'm
because
doing wrong.
3.5 is your mean.
Right, that's our mean. Okay. And then divided by 0.078, square root of 81. Is that right?
Uh,
The n is 81. The sample is 81.
yeah, so you 3.3 minus 3.5
Right.
divided by 0.7 divided by
Oh, okay.
the square root of 81.
Got it.
So pretty much it's just, what was it? 3.3 minus number minus number 12 over number 13.
So you got a negative 2.564.
571.
Oh, okay.
So then,
So I'm sorry. So we had to put that in the applet for that one.
14, yeah.
Let's see.
And then you want it less than 3.3, so you want it less than that z-score.
Okay. So what was the probability that you got? 0.9948.
No, it's 0.005. You're wanting to the left
Okay.
of the negative.
Oh, just the little tail then. Okay.
Yeah.
Okay.
And then 15 is you want it to be greater than. So you're going to have it to the right of the
Okay.
negative, which is
so be
the
the middle
99.
So we use the same data, and we're going to put in the applet, and now we're going to the right. Okay.
Mm-hmm. You highlight everything to the right, so that's what you were just saying. You were just
Oh, okay.
highlighting it from the other end.
So 0.9948, or
Yeah.
0.95.
95.
Yeah.
Yeah.
Well,
Okay.
we would submit it.
Do we want to go over it one more time, or it's long?
Yeah.
But-
I feel like we did it pretty well, so I'm
Yeah.
okay with submitting it.
All right. Victoria's usually the first to trigger it. Go for it.
Okay. All right, 100%.
All right.
Awesome.
Yay.
Oh, we have to do our ritual 5. Virtual
Oh, yeah.
5. There.
Oh, I'm not there yet. Okay. Woo! We did it. Yay. That one I feel like really worked my brain today.
Yeah, it was a little bit more complicated.
I'm glad I have help.
Well, awesome. So I will see you guys on Tuesday then.
Okay.
Yep.
Sounds good. Victoria, will you be around at all this weekend if I need your help?
Yeah, I should be. I was not on my computer last time most of the day. So,
Yeah. Okay.
yeah.
I have homework to finish, so sometimes I need a little help. So, okay.
Yeah.
Thank you. I appreciate that.
Uh-huh.
All right.
All
Signing
right.
off. Bye. Have a good night.
Bye. Bye.